Hey guys, Miss Beasley here. I'm here to talk to you guys today about dimensional analysis. It can really be easy. We have realized, a coworker and myself, that online videos are not the easiest way. I had not looked at the online videos myself prior to teaching it, just because I learned it over 20 years ago. I'm confident. And then my coworker brought it to my attention that the videos were doing it the opposite way, and it just makes it more difficult. So I wanted to give you guys some videos to reference so that you can realize that it really is easier, even if you haven't sat in on my lectures. So dimensional analysis is easy to use once you get the hang of it. And I say that I'm a spokesperson for it because since you do most of your conversions inside the equation, it does make the equation longer, and I get a lot of people's argument about that, but it also prevents you from having an error, not only with the conversion being outside of the equation, but also if you plug the units in incorrectly with the other types like desired over have or ratio and proportion, then you just have a greater incidence of error. So with dimensional analysis, it's all going to be in the equation itself. Even if it does make it a little more math in the beginning, right? That's okay. So we'll start just with a couple basic things. So say we have an order for atenolol, 100 milligrams PO daily, and the pharmacy only has available 50 milligram tabs. So how many tablets would the nurse administer? Well, you can kind of eyeball this and see how many tablets you need to administer, but it's always good to practice even the simpler equations until you become more proficient with the dimensional analysis. So with dimensional analysis, what we do is we work from left to right, and we start on the left with our desired unit of measurement at the top of the equation. So what is our desired unit of measurement here? How many tabs is the nurse going to administer? So we have tab here. And what do we know? We know that we have 1 tab equals 50 milligrams. So 1 tab over 50 milligrams. And then our desired dose is 100 milligrams. And that's all we have in this equation. So then we'll just put over dose, which you can tell yourself just means 1, because we want to cancel out these milligrams. So we'll have those. With dimensional analysis, we simply multiply across the numerator and the denominator. So we'll have 1 times 100 is 100 over 50 times 1 is 50 equals 2 tabs, because we had tabs left, right? So the answer being 100 divided by 50 equals 2, and so the nurse will administer 2 tabs. So that one's super easy, right? But the thing with dimensional analysis, like I said, we put everything in the equation, so when it's not these super easy ones that you can eyeball and say, oh, I'm gonna give 2 tabs that equal 100 milligrams, then that's where it's really gonna help you the most. So let's think about a different equation, a more complex equation. So say we have an order for 280 milligrams of acetaminophen times 1 PO now, and the pharmacy has available 80 milligrams and 2.5 milliliters. So when we're looking at this, it's not as easy to eyeball, right? So then we want to turn around and we're going to put this into dimensional analysis. So we know that we have to give 280 milligrams, and we have 80 milligrams and 2.5 milliliters available from the pharmacy. So how many milliliters are we going to give this patient? Since milliliters is going to be our desired unit, we're going to start with that. We have 2.5 milliliters in 80, or with 80 milligrams. So that's our starting round, and we got to work our way across from left to right over to where dose is at our denominator. So we know that we have our 2.5 milliliters at our 80 milligrams, but our dose is 280 milligrams. So we've got 280 milligrams over the dose. Again, we just multiply across. So 280 times 2.5 is going to be 700 divided by 80, because 80 times 1 being our dose, equals, it's going to be 8.75 milliliters. So then you would round based on what your rounding is required for your test in your school. It depends. It may be, so if you're rounding to the nearest hundredth, then you're already there. But if you need to round to the nearest tenth, then you're going to round up to 8.8 milliliters. That's how many milliliters you're going to administer to give 280 milligrams to this patient. Okay, so we can move on and get a little bit more complex. How about that? So let's throw some weight in there, right? Where we got to put a few more conversions in this equation. So say we have an order for augmentin 20 milligrams per kilogram per day in 4 divided doses to a child that weighs 66 pounds. Okay, so what I say? 20 milligrams per kilogram per day in 4 doses. And the child weighs 66 pounds. Okay, and the pharmacy has available 150 milligram tablets. Okay. So, now that's a lot to put in there, right? We can't eyeball that for sure. My brain cannot. So, we're going to start. What is our desired unit? We need to know how many tablets to administer to the 66-pound patient that will equal 20 milligrams per kilogram per day in 4 doses, right? That's a lot of information. So, we're going to start though with our tablet because that's our desired unit. So, 1 tab is 150 milligrams. So, 1 tab, 150 milligrams. Where else is milligrams? We've got 20 milligrams per kilogram per day. So we'll put our 20 milligrams up here because working across, we've got to cancel out everything except for tab and our dose at the end. So 20 milligrams per 1 kilogram, because it's 20 milligrams per kilogram per day. And now we've got to cancel out kilograms. So also 1 kilogram equals 2.2 pounds, because we've got to figure out how much the 66 pounds is in kilograms. You would convert that on the side with other types of math, but with the dimensional analysis, it's all right here in the equation. So 2.2 pounds, and then we'll have pounds up here because we've got to cancel out this pounds down here. So 66 pounds over what? So we're going to do in 4 doses over the course of a day is 20 milligrams per kilogram per day in 4 doses for our 66-pound patient. So we're going to do 1 day here, and then in 1 day we do 4 doses. So there's our dose right there at the end of the equation. See it a little bit. So now we're just going to multiply all the way across the numerator and all the way across the denominator to get our answer, because all of these, the milligrams, the kilograms, the pounds, and the day, those are all being canceled out. So we'll have our numbers and our tablet for dose. So when we multiply that across the way, it's going to be 1320 over 1320. So we're going to give 1 tablet. That was a lot of work for 1 tablet, wasn't it? But the thing with dimensional analysis is it's all right here in this equation. So you don't have to convert the pounds to kilograms over here on the side. You don't have to do your 20 milligrams per kilograms times those kilograms over here on the side and then plug in otherwise. It's all right here in one big equation. So seems harder in the beginning, but it's truly not harder. All right, we can move on to something different here. Okay. Now then, we can do IV, because as I said, generally with dimensional analysis, you start on the left side of the equation with your unit that you you want, and then you work your way across with dose as your denominator at the other end and cancel out everything in the middle. But whenever you're doing IV drips, it's even easier, because if you're doing milliliters per hour, you start with milliliters on the left side of the equation, and your denominator on the right side is hour. Or if you're doing drops per minute, you start on the left side of the equation with drop, and the right side of your equation will be minute. And you just work everything out across the way there. So let me see, for example, we can do, so say we have an order for 250 milligrams to infuse over 2 hours, or 250 milliliters to infuse over 2 hours. So if we're doing milliliters per hour, that is pretty easy. We don't even have to do dimensional analysis all the way across, because we have 250 milliliters by 2 hours. So then we just divide that, and we have 125 milliliters per hour. So that one's super simple because it just has 2 components. But what if we need to do something a little more complex again? So what if we need to infuse 250 milliliters over 90 minutes? So then we've got a little bit more to add in there. So we'll start with our milliliters because we're looking for milliliters per hour. So we have 250 milliliters that we're going to infuse over 90 minutes. But we need hours to be our denominator, right? So we got hour over here. How many minutes are in an hour? 60 minutes in 1 hour. So that cancels out our minutes, and we have milliliters per hour left. So we just multiply across. So 250 times 60 is going to be 15,000 divided by 90, because 90 times 1. So that is a bigger number. I understand, like I said, some people don't want to do the bigger calculations, but it's all here in one problem, so it makes it easier. So when you do that division, it's going to be 166.6666. But you generally, with milliliters per hour and of course drops per minute, because you can't give half a drop, you will always round those for in testing generally to the nearest whole number. So in that case, we're going to give 167 milliliters per hour. So all in one equation, easy breezy. That's why I'm a spokesperson for dimensional analysis. This is the easy way. Those online versions have you doing it backwards, but it's much easier this way. So now if we want to do drips per minute for someone, so say we want to infuse 250 milliliters over 2 hours with a drop factor of 10 drops per milliliter. So, all right, and if we're looking, we want to do drops per minute, so we start on the left side of our equation with drops. So what do we know is a drop? Our drop factor is 10. That's per 1 milliliter. Let me tap that right here. Okay, and then what else do we have that's milliliter to go over here is our numerator. That's going to be the 250. That's our volume to be infused. So 250 milliliters, we're going to give that over 2 hours. But we're not done yet because we need minutes to be our denominator over here. So we know that 1 hour equals 60 minutes. So then everything that's pertinent in this equation is in our equation here, and we just multiply across the numerator and denominator so that we can get our answer. And that's going to be 2,500. My pen is not wanting to work. We'll get 2,500 over, what, 120? 120 equals, it's going to be 20.8333 blah. Remember, drops, you can't give half a drop or a quarter of a drop. So you're just going to round this to the nearest whole number. So you're going to give 21 drops per minute. That's what you're going to count in that tubing to make sure that you're giving 250 milliliters over 2 hours. We got that? All right, that's pretty easy, right? We can do another one of those. just to work it out a little further. So say we have an order for 1,200 milliliters to infuse over 6 hours. Okay, and we have a drop factor of 20 drops per milliliter. So again, we start with, we want drops per minute, so we're gonna start over here with drops. So we got 20 drops per 1 milliliter. And we know we want to infuse 1,200 milliliters over 6 hours. And 1 hour is 60 minutes because we want drops over here on the left side of the equation and minutes on the right, and we're going to cancel out our milliliters and our hours. So multiply across and multiply across, and we're going to get 24,000 over 360, which is going to equal 66.66666. So then we'll round to the whole number again, and we'll have, our answer is going to be 67 drops per minute. It's all here in one equation. So definitely makes it easier. Alrighty, let's see. We can go back, see if there's anything else we can do. Anything a little harder, anything we could throw some more in there, some more different types of questions, maybe some advanced calculations. How about we're doing a heparin drip? Let's do that. We want to infuse 900 units an hour is our goal. And the pharmacy has the 25,000 units in 500 ml bag, those common bags for heparin. And we want to set our pump at what IV rate, milliliters per hour. So with this, we're going to start with milliliters because we want milliliters per hour. So we've got to start on the left side with milliliters and work our way to an hour on the right. So we know that 500 milliliters is 25, not like that one, is 25,000 units. And we want to give 900 units per 1 hour. So we'll cancel out our units and multiply across, right? So that's going to then equal 450,000 unit, or 450,000 divided by 25,000, because we just multiplied across, and that will put us at 18 milliliters per hour for our heparin drip, which now those are almost always calculated by the pharmacy because thank goodness nursing don't have to do all of the, does not have to do all of the equations now, hooray. So, all right, let's think a little bit more complex type of drip like that. So what about a Norepi drip at 12 micrograms per minute? And we have Norepi 4 milligrams in 250 milliliters. So what's our milliliters per hour gonna be? We know we're looking for milliliters per hour. What'd I say? 12 micrograms per minute. And we have 4 milligrams in 250 milliliters. Okay, so we're gonna start with milliliters because that's the left side of our equation. We're starting with milliliters, end with hour. So we have 250 milliliters, has 4 milligrams of medication in it. And the dose is for 12 micrograms. Well, we've got to go ahead and convert this, and everybody here knows the conversion from milligrams to micrograms, right? Because we're nursing students or nurses, and we got this. So 1 milligram equals 1,000 micrograms, and our dose is for 12 micrograms per minute. And we know we've got to get hour over here. So how many minutes are in an hour? 60 minutes per 1 hour. Okay, so now our milligrams all cancel out, our micrograms, our minutes all cancel out, and we're just going to multiply across our numerator and our denominator, and we're going to get 180,000 divided by 4,000 equals 45 milliliters per hour for our answer there. So that is it. I hope this helps some of you guys. Like I said, way easier than the online versions of dimensional analysis and way easier than converting them on the side and trying to plug them into desired over have and ratio and proportion, in my brain anyway. Everybody's brain is different. I understand if you don't love it, but I did want you to just see something different than what they're doing online. So, like I said, big step. Just remember your desired unit is on the left of the equation and you're working your way over to your dose. Or if you're doing milliliters per hour, you're working from milliliters to hour, and drops per minute, working from drops to minute. Multiply across the numerator, the denominator, cancel out everything that's in the middle here. And hopefully you will be more successful in the long run. Thank you guys.